Dear friends, good afternoon. We are starting our work. This is Data Science section. My name is Oleg Boguslavskyi. I'm the co-founder of Data Science UA. And frankly speaking, today we will be discussing exclusively about some practical cases of applying data science, how we apply data science in business, and what Ukrainian startup companies are now good in this field. And I'm so much happy that I have worked for two companies which we know in which artificial intelligence is very well known about. I know a lot about it, and I've worked for in Ukraine, which was a unicorn company, was sold to at $1 billion. I also worked with Sfera Automotives, which I think will one day become a unicorn sometimes later. So I will tell a little about what we are going to do right now. There will be four interesting presentations, and we got a guest who will be conducting his presentation in English, and following the presentation, once we have the panel discussion, the entire panel discussion will be in English. So if somebody doesn't speak English well, you can grab the earphones, special earphones, and our interpreters will be working for us all through the day, and they will be able to interpret to you. So they will translate both into Ukrainian and into English. And if you've got some issues with your foreign language, use the earphones. So I'm not going to be lingering any longer. Let's start with the first presentation. It's a great pleasure of mine to invite to this stage Nika, Tamayo, Flores, head of the Data Science UA Consulting, and only practical cases today during the data science. Thank you very much. Good afternoon.
There would be more than one person speaking English now on the stage. So while we're waiting for my presentation, I will introduce myself a bit. You know, it's always interesting because sometimes things just don't work. And it's especially funny when you talk about artificial intelligence. Mic is not running, you have no sound in your headphones, your presentation is not running, there are some troubles with projections or stuff. That's always happening, so technology is around us. And today we're gonna talk about artificial intelligence all the way through these 2 hours. So I am Nika Flores, and I'm partner and head of consulting at Data Science UA. I started my career as a marketing analyst, and then I fortunately figured out that there is something more about analytics than just crunching numbers in Excel. So I figured out there are such things as, they called it big data that days, you know, in 2010, 2014, they called everything big data. All the things regarding data were called big data. So I figured out there is a thing called big data, and then eventually get to the artificial intelligence. And now, more than 4 years, I'm working with different projects all around the world, helping companies with their digital transformation, with embracing the power of analytics, and with working with data, numbers, images, signals, and all the different kinds you can imagine. And a few words about Data Science UA. It's all started in 2016 with the conferences, and until now we've had 9 international Data Science UA conferences with cases, business track, and tech track, and with all of this technical and creative energy power in here. But more than that, we are also doing a lot of educational events, workshops, meetups, courses, and stuff like that, because we do understand that there is not enough people in this area, and as you may know, World Economic Forum and organizations like that are projecting that we would need even more of the data scientists, even more data analysts, even more business analysts and people like this in the coming years. Not only that, also, we're helping companies with their digital transformation. We're helping companies to find the right talent for their projects and to create their dream teams. And apart from that, our latest edition is helping foreign companies to build AI R&D centers, research and development centers here in Ukraine, and hiring and managing this kind of companies for them. But the truth is, not always you need the greatest technology available to do your business great, right? You need to understand what is it exactly that you need? And sometimes that's a very tricky point, especially if you're overflown with data, if you have a lot of legacy systems, if you're having different functions that are not working well together, and figuring out how to find the right way through this emerging field, through this storm of different data and of different things, that might be a very, very hard thing. So that's why we're introducing someone called Data Pathfinder, a person who helps companies to find their way through the technology. And I will tell you now why do you need to find this way at all. So the thing is, there are 4 levels of analytics, if we could put it simply. And many companies, they just stuck on this first level. This first level would be the descriptive analytics. What happened in the past? What happened last month, last week, yesterday? I mean, somewhere historical. What happened there? And having this information, that's just not enough to make a decision. Okay, so we know that last month we've sold X amount of ice cream, or we attracted Y amount of client, or something like that. Well, okay, what's next? What are we gonna do with this information? But many companies, they just stop there trying to analyze the past in order to make some predictions for the future. Next, what we need is diagnostic analytics. So why does it happen? Why our results are like that? Why do we have these numbers? Why do we have that number? So what's happening there? And to figure out what are those factors that do influence this past things, this historical data, we need to make some factor analysis, to run some regression models and things like that, to figure out what are those factors that can help us to make our decisions better. And of course, the world is very complex. We cannot find all the factors that influence this decision, or sometimes we cannot influence those factors. For example, speaking of selling the ice cream, well, weather influences how much ice cream do you sell, but you can't really influence the weather. Well, until now it wasn't possible, but maybe somewhere in the future you will be able to do so. So you can't influence the weather, but you need to make some decisions based on that. And working with diagnostic analytics help us to find some insights, some useful information that will say us, okay, so every +1 degree in the weather helps us to sell X tons of ice cream, for example, or things like that. And figuring that out, that might be crucial for business success in the future, if you're in the business like that. But that's just the second step of the analytics. Then you would go to the third one, to the predictive analytics. Okay, you know the past, you know what influences your key indicators, so now you can make some projections in the future. Having weather forecasts and things like that will help you to project how much ice cream you will be able to sell in the future. And this is a stage where you can already use some pretty complex models and pretty advanced algorithms and pretty cool artificial intelligence to help you with that. But that's also not the end of this system. You have the last part here. That's a prescriptive analytics. Okay, so you know the past, you know what influences the past, and you know pretty much what are you gonna get in the future. Well, at least approximately. Then you may just go and do something to make it happen. You just flip it, and you don't focus on how much you want to get, you focus on how you will get that much. And that's a very interesting idea, because this is the holy grail, that's optimization. This is the part when you sometimes don't even need humans to make decisions. And this is the part where artificial intelligence plays a very, very great role. But what is AI exactly, right? Everyone's talking about that, and there is no one single definition, even though the field has been around for more than 70 years. So let's put it this way. Artificial intelligence is the ability of a machine to make some kind of decisions, to make some kind of human-like decisions, like analyzing the data, finding some patterns, and saying, okay, what to do next. And a lot of people, again, jokes and asks me, are we going to get the Matrix? Are we going to get the Terminator? So when should we get ready for that? When the machines will take over the world? But the truth is, well, they're not even close to taking over the world in that meaning, but they have already taken the world in another meaning. We're using our mobile apps to build the routes to get to our work. We're using our mobile apps and not only mobile apps, we're using different kind of stuff to say, what are we going to watch this evening, where are we going to eat, whom are we going to read, and things like that. In what hotels are we going to stay, where are we going to go. So algorithms in a way have already taken the world, but that's not so scary as you might think of it. And actually, you can find the examples of this neural net, and this is the image made by a kid, and some scientists made a neural network to try and figure out, okay, if this animal would exist, how would it look like? So people are concerned even with things like that, not with taking over the world. But there are a few things in business where artificial intelligence is really good at, and it may help you solving this kind of tasks. The first one would be finding patterns. Okay, people are also good in finding patterns, but the patterns like a lion in a savanna, you know? We're not good in finding patterns when we're having a bunch of numbers and huge Excel tables with hundreds of rows. We're not good at finding these slight changes, and machines are good at that. They're good at finding different patterns. They're good at figuring out how things are connected, how they are correlated, how can they work together, how can they influence each other. So things like that are nice things to be passed to the artificial intelligence in working with. Another thing that AI is already very good at would be image recognition. For some tasks, AI already performs better than humans in recognizing some objects. Well, the difference is not that big, like 1 or 2%, but still it's better. And another good thing would be that AI never gets tired, you know? So you can just pass some mundane routine tasks to the AI and work with that. The third thing would be complex calculations. Well, that's connected to finding the patterns. For most of the people, math is something that's hard. It's hard to make some complex calculations, to work with the multi-dimensional space. Most of us cannot even imagine a space that has more than 3 dimensions. And machines can work with a space with 500 dimensions and whatever number of dimensions there is. And for some tasks, that would be a very important thing. So the truth is, AI is not only good at that, AI is good at being less wrong than humans. You may imagine, for example, a doctor, a neurosurgeon who works with people who have brain tumors and things like that, and imagine that this doctor has 40 years of experience. So you might think that, well, this doctor, he or she have seen hundreds of patients, thousands of patients over this huge career, but machine over 1 year could see 2 million of cases, 3 million of cases that would never get tired and would be better at making some of the decisions, only some of the decisions. So the best thing about artificial intelligence is it is a great augmentation for humans. We're not talking about machines that take over the world. We're talking about humans who use machines to take over the world. That's what we're talking about. And you know all of those companies, and you use most of their products every day. And by the way, when I was putting Nvidia logo, I wasn't thinking about you. I didn't know that you would be here. So yeah, but that's a curious situation. So you're using most of or at least heard about all of those companies, and all of them are using different kinds of neural nets and algorithms and model to make our life easier, to make our life better, and to make money, of course. But, okay, if you're not Tesla, if you're not Tencent, Nvidia, Facebook, or Google, how can you use AI, right? So that would be the basic question that I would get from you, I hope. If you don't have that much money, if you don't have that much power to attract the greatest talent possible, what can you do just right now to use AI? Because that's no longer an option. So you can automate your routine processes with some basic things like RPA, robotic process automation. There are so many tools on the market just right now, starting from the workflows that are built in Microsoft Azure services, or another cool app called Integromat, or all the other API-like systems like Chorizoid, for example, that would help you to connect different systems all together and to get some very specific things done. For example, copying some information from the email to your CRM system. That can save time if we're talking about bigger companies. Or you can automatically issue invoices, or you can automatically classify documents and things like that. Pretty straightforward, very routine tasks that have a very exact algorithm of doing, okay, first you do this, then you do this, and then you do that, and voila, you're done. Another thing would be getting cognitive insights. Let's say you're a financial organization, and for example, you're giving loans to your customers. So you need to figure out what are your good customers. Good customers would return the loan and percentage, and the bad customer, well, obviously will not. So you need to figure out what influences this behavior. How are those customers that do return loans are similar, and how do those customers that do not return loans are similar as well. And finding those differences will help you to make your strategy and to give loans only to those who really need it and who can get that back. And that's the business goal. Artificial intelligence and models of machine learning may help you do that, may help you distinguish between these two classes of customers. Or you may get more different insights. For example, if we're talking about retail businesses, retailers do have different kinds of customers as well. And sometimes they do think about them like, okay, that's women 24 to 36 with 2 kids and stuff like that. But demographics is no longer something that describes the audience precisely. Imagine fishing. You may have a girl that's working in QA automation, has like 24 years living in Kiev and driving red Mazda, and she enjoys fishing. Or you may have a guy who has a really old Volkswagen, for example, and he works as an engineer on some plant, and he really likes fishing. So what is the similarity between them? Well, they like fishing, and that's it. They have different gender, different age gap, different situations in their life, different financial situations, different education. All those things are different, but they do have something similar that would make them go to the fishing shop and get something for their next adventure. So finding those patterns, those behavioral things that make your customers similar, that's another task for artificial intelligence, and this is one of the most easy tasks. Getting the customer clustering, for example, that's considered one of the easy tasks here. And you can use artificial intelligence to reduce error. If you're making some of the decisions in a very straightforward way, let's say you're parking fines, let's say, right? There are only 2 ways of you're parking the right way or you park the wrong way, and like there is no other option. So you may get these decisions automatically as well if you know what is the right way and what is the wrong way, like a parking inspector. So reducing errors is also another thing that artificial intelligence can help you with. And now coming to the smallest but nonetheless very interesting part of my talk. Okay, how can we cope that being here in Ukraine, again, not in US, not in China, that have that much potential in artificial intelligence? What can we do here in Ukraine? Well, as Oleg already mentioned, we have quite a bunch of very, very inspiring and interested companies here in Ukraine that work with artificial intelligence. Of course, that's not all of them, just those that got to my slide, with you being able to read those logos. So we have a huge amount of talent here, and we have a huge opportunities here and huge possibilities here. So why Ukraine? Why having Ukraine as a bigger player on the AI market worldwide? Apart from talent that I've already said, we also have the greatest speed of testing. You may use Ukraine as your starting point, as your beachhead market, and then expand with your AI products, with your AI solutions to whatever market you see possible. And the last, but not the least, would be taxes. Well, everyone's talking about taxes and saying, well, we have too much taxes, but the truth is not. If you would go and see what are those tax models in different countries, you would see that Ukraine has one of the most interesting ones among all of them. We'll see what's going to happen with DSCT, but for now, we're still having the best taxes possible. So Ukraine is a great place because of the talent, because of the speed of testing, because of the taxes that we're having to test your new and great AI ideas. So that's pretty much it from my side. So you can follow us, our Facebook page, using this QR code, and I would be happy to answer 1 or 2 of your questions, right?
Так, друзі, ми маємо час на 1 чи 2 питання, також ви зможете задати більш...
Yes, friends, we have a couple of minutes for the questions that you can ask Nika, and you can also ask her a couple of questions during our panel discussion.
Are there any studies which research how actually affects implementing such programs, implementing data science and AI to the main business metrics like net profit, etc.?
Yeah, of course, thanks. You can refer to, for example, the World Economic Forum research or McKinsey Global Institute research that says that companies that do implement AI has, if I'm not mistaken, like kind of 16 or 17% more chance to get to the break-even point and to get all of those metrics in a more... I'm sorry, I just don't remember the exact numbers, but there is definitely the research of the McKinsey Global Institute that says it like in a plain text. Okay, cool, thank you.
Так, Ніка, дуже дякуємо.
Yes, Nika, thank you very much indeed. And now it's a great pleasure for me to invite the next speaker, Vasyl Pasternak, CEO or the head of R&D office of Nvidia. A lot of people in Ukraine don't even know that we have an office of Nvidia, but those people who are into data science, they know that Nvidia is one of the key players in the world market, one of the key drivers that keeps driving this train of data science and AI. So, Vasyl, the floor is yours. Data, structure, accelerators. All of us, we know what is CPU, we know what GPU is, and now Vasyl will tell us what DPU is. Thank you, Oleg. It just so happens that you have already shared part of my presentation. Yes, I'm the director of the Kiev office of Nvidia here in Kiev. This is something that we deal with, research and development. We deal with technologies for data centers, and today I will share about the future of data centers, what awaits us, and where we are headed. Nvidia, a lot of you may have heard about technical adapters. For some, Nvidia is associated with Bitcoin, but Nvidia is also a big platform. There are servers, AI chips for parallel processing of big amounts of data. Our devices are components of big supercomputers. They are components of big data centers used in a lot of corporations, medical facilities, for modeling, for retail, etc. Additionally, in addition to processors and chips, Nvidia is a huge platform that combines a great number of SDK, a great number of developers. On the basis of this platform, Nvidia manages to build various startups, companies, and they build their solutions. Among these companies is Microsoft, Google, and some other ones. So, talking about data centers. First of all, I would like to show you this graph. Now, this is not the graph of our shares and stocks and shares growing in price. It's a bit more steep. But due to what we have, we now have computers which are more powerful on our wrists than the computers that landed people on the move. Gordon Moore, one of the founders of Intellect, he said that with every generation of processors, they will get twice as speedy. They will always have twice as many transistors. The space will be half of that, and they will consume half the amount of energy. And this has been true for the last 40 years. However, starting with the zeros in the mid-zeros, you may have probably noticed that basically processors are not getting more powerful anymore. We have arrived at the boundaries, the confines, the limits of these processors getting as powerful as they can. So expectation that processors will be able to resolve all of these bottlenecks with the great trouble of having this huge data amounts It's not something for us to expect. They started to say, let's have several cores, several different processors, but it's just one of the methods to resolve the problem. Another method to shoot the problem is to go to data centers. Data center boom, starting with the most basic ones, monolith solutions that would just resolve one problem, or all the way to software-defined data centers, built on the basis of cloud models and microservices, where applications in fact migrate not only within the boundaries of one host or one server, but they can migrate across the whole data center or even several data centers if they are disconnected. So all of that enabled us to expand the amount of data that we can calculate and that we do calculate in order to not lag behind this world of data that keeps coming up. On the other hand, it also puts certain limitations on the processes themselves, because if previously our processors used to deal only with the tasks that we needed, some useful for the users, then with the arrival of virtualization, with the arrival of the clouds, then processors had to deal also with maintaining the whole infrastructure of the data centers, creating a virtual applications, different networks that allow you to access these centers to ensure the cybersecurity of these centers. These yellow cubes, in a way, this is the processing time which is taken up, which is in no way connected to troubleshooting the tasks or solutions necessary for the users. This is the processing time necessary in order to maintain the work of the data center itself. So when we learned to use GPU, the graphic processor, to resolve some calculation problems, you know that they can resolve some tasks of deep learning, AI, and some neural networks. They can handle that well. So thus we raised the productivity of our processors. We relieved some of the workload from the central processor and transferred it to GPU. And in the same way, we came up with an idea. Why don't we try to relieve part of the workload on the management of data center, data management, and also transfer it on a separate chip that can also perform these respective tasks. So Nvidia recently announced DeepU, Data Processing Unit. Another name is Nvidia BlueField. There's already a third generation of the BlueField, which has been announced and will be supplied starting next year. Basically, this is a processor. It's a networking adapter together with an ARM processor, which goes on the same chip and enables you in real-time terms to process all of the incoming data, emulate all of the devices. It may also be fitted in CentOS, Linux, Syntaps, and any other systems. And you can also install any programs that you may be interested in. I'm not going to linger any longer in this detail because I can take a couple of hours of your time, because that's exactly what we are dealing with now. Let me give you a few examples of how it can be used and whether it can be interesting and how this may change our future. The first illustration, this is GeForce Now. GeForce Now, it's a cloud gaming platform that allows the users from different corners of the world, from their mobile applications, televisions, telephones, launch a game and play on other devices that basically cannot launch a good 3D toy. It's a very demanding in terms of its latency, performance, speed of data transmission service, which optimizes virtually everything, starting with how these servers will be placed in a certain territory, because they have to be called. So in a traditional gaming server, you can see that we have a server and a processor, which is marked in blue. It serves the clients, but in addition to servicing the clients, it also engages in such things as security, telemetrics, protection from different attacks, supply and data center, access to data, etc. And down at the bottom, if you can see also Ethernet NIC. This is the usual network adapter that provides you with the necessary data, and then the processor keeps doing its work with it. Starting with Bluefield unit and its application, that's something that we are already using as a setup. All of the stuff that is completely irrelevant to real work of the processor, I mean, in terms of servicing the clients, the sessions of the clients are transferred on Bluefield, and they help us, firstly, to accelerate all of that. Secondly, they relieve the processor from all of the redundant, maybe secondary importance work, and thus exceed the number of clients per every host by 10 to 15%. The second example is more to do with corporate. This is Monterey project. We are doing it together with Nvidia, Dell, and Bear. This is a corporate system for building and emulating management of virtual machinery. So you have a server and you install XI platform on it, and there you can have a great number of virtual machines, and the users may be anything. That may be a banking facility, operation is working for bank facilities, so they get connected to the system from their standard workstations. These may be even thin clients, doesn't have to be even a powerful computer. They get connected and proceed working. So this is one of the foundations for the majority of clouds. And ESXi, it's a hypervisor whose work is to manage virtual machinery, virtualizing all of the devices for input, output, management of network, virtual security, management of the whole machine itself, I mean the host management. It's one of the aspects for the administrator to administer all of the machines remotely. So now we are working on a project that will transfer part of the functionality of ESXi on Bluefield, and thus it will relieve a lot more working processing time and capacities in order to service the virtual machines of its clients. And that, in its turn, instantly will allow us to increase the number of the customers we serve without actually adding a single server, but just by supplying a small chip for every server. Along with that, as we were implementing that, very interesting additional peculiarities and features emerged once we begin to use DPU. For example, security-wise, DPU will enable us to protect ourselves from DOS attacks in a more efficient way. DOS attacks, what are they? If an evil hacker begins to load one of your machines with the data, necessary data, and thus it blocks the working operations of this particular machine. And if in an imaginary host where DP Bluefield isn't working, there is a DOS attack for one imaginary machine, virtual machines, that will mean that central processor will have to disconnect and begin to put different barriers and blocks in order to repel that attack. And automatically, this capacity that the processor will take will immediately slow down all of the virtual machines that work per this virtual host. And that's nothing that can be avoided. So a DOS attack will immediately slow down all of the virtual machines, no matter how many they are. Once we begin to use Bluefield DPU, the protection from DOS attacks will be the job of Bluefield. It's not something that the processor will have to be responsible for. It will be rendering graphics. It will be launching various applications without actually knowing. It will be it will not care whether there are any DOS attacks against it. So it's one of the interesting peculiarity which is only achievable with the arrival of such additional DPUs. It's just a couple of small examples for you. Even now, we may see how widely this is going to be used. For instance, DPU will become the foundational for new 5G and 6G networks and load balancer, protection of and encryption of data, decryption of data, video streaming. All of this can be also done through DPU to make sure that the central processor does very important work, the necessary work to generate real profit. Alongside the chip itself, Nvidia traditionally presents a whole platform. This platform is called DOCA. DOCA, data center on chip architecture, which will allow vendors, real developers, usual developers, to write solutions and programs that will work on DPU and accordingly expand the functionality and the opportunities for what data centers will be able to perform. They become huge as a result. We have a pool of partners that we are working on currently. Basically, these are some of the traditional tasks for data centers, that cybersecurity management, storaging, and I guess rather quickly even bitcoins can also arrive on this platform. In a nutshell, that's it. That was just a brief description of what we are to expect in the future. Thank you for your attention. If you have any questions, you're welcome. So far, the price hasn't been announced. It's just an announcement that we are making within the community via this presentation. Good afternoon. Could you please tell us, if we are a system integrator, what are the options that we have to cooperate with you only as a vendor and distributor, or can we directly interact with you, learn from you? Thank you. If we are only talking about Office Nvidia, that we only have the R&D office, we don't have a distributor here. Therefore, it's only via the official distributors that Nvidia works with. Hello? I don't have a startup or a big company, and we are working on a cloud gaming. The cloud gaming you were talking about. Not a single game, unfortunately, gets launched in the cloud so that the users can play it easily. According to your forecast, when can people apply this technology fully? Because you are within your offices and the best demo options are launched for you. But then when the best shooters and sports games, do you think will be launched in a full-fledged way without any problems of data transmission all the way from pressing the button and all the way to the system in a cloud? Well, in our office, they don't allow us to play with any toys of the kind, but basically understand what you're on about. Because we want to optimize data centers, the last mile in many ways depends on the providers, on how these packages will be transmittable. So what's your forecast? Well, my forecast is just creating smaller data centers closer to the final users and customers, not to create a big, huge data center somewhere in the center of Europe and all the way to China, but to create something in Ukraine, launch it in different regions of Ukraine, depending on the number of the clients, and then optimize the traffic, especially the last mile of it. And in many ways, it also depends on gamers themselves. If they want to have a fine experience, they also should hassle with having the right router, the right provider, and stable pin.
Thank you very much, Vasyl, and I think that those who are not good in computing, they've been watching this presentation, they go, wow, Nvidia, Tesla, well, the scale of Nvidia and Tesla are similar.
Now we should switch to English because I'm very happy to introduce our next speaker, Jean-Christophe Bonis. Jean-Christophe is the futurist entrepreneur and TED speaker, and he is also co-founder and managing partner of the Nextcorpo. This is the VC fund. And, now we'll talk about the real future, and, now we hope to hear a lot of insights of what we'll see with AI in the future. Although the name of the presentation today is AI doesn't exist, so we'll find out whether it exists or not. Jean-Christophe.
Very nice to meet you. So good to be back on stage. That's a couple of boring speaking in front of computers since 1 year and a half. My name is Jean-Christophe Bonis. I'm very used to coming in Ukraine since more than 10 years now. Obviously, with my French accent, it's still working well. I decided today to face a challenge. Speaking in front of people specialized in data science and explaining them how AI doesn't exist. I'm French. I love challenges. So AI doesn't exist. Let's explain the things. We are dreaming since more than 10 years about AI, artificial intelligence, the dream of a new world and everything. That's a dream, guys. It's just a dream. Data science, it's cool. It's mathematics, statistics, artificial intelligence. Intelligence. It's not existing at all. Let's begin by the beginning. No misunderstanding between us. We can do amazing things. Here is MIT algorithm, able 5 years before to explain and to see if you have a breast cancer or not. 5 years before, just with data. Data science, mathematics, statistics. Amazing, not intelligence. Data science. This is a car, thanks to my friend from Nvidia. They are doing an amazing job. Self-driving, soon we will have that everywhere. Amazing, the car doesn't understand at all what it's doing, at all. Data science, statistics, mathematics. Here it's our friend from SpaceX. Again, it's algorithms, mathematics, able to, in real time, adapt trajectories. It's amazing, huh? That's crazy. We will face a new race in space, polluted space after Earth. Lovely. But still, it's nothing in link with intelligence. What I try to explain you is the fact that we are speaking about artificial intelligence, but at the basics, just the fact we are using the name artificial intelligence is a huge fake. Because it's nothing in link with intelligence. We are trying to cheat on population, to cheat on people, explaining them how much we are able to create something that is artificially intelligent. We are even not clever ourselves. So let's try to see what is artificial intelligence. My friend earlier, my colleague earlier described it, so I will try to describe on another way. Basically, when we created the internet, we needed to be able to access internet, to have a search on web, and Google arrived with indexation of the web. This indexation was done with words. You write on Google, on Yandex, on everything you want, and you find information on web by words. Cool. Internet 1.0. And after, someone called Steve Jobs decided that media is quite interesting to put inside a smartphone. You began to have iPhone, and now we have not only iPhone or media by iPhone, by Samsung, or anything else. We can see the words by media. But it's a problem for a computer, because when you want this lovely lady on Instagram to find this top, how are you doing? Words, alors, so pullover, grey, fashion show, Paris, girl, millions of pages. And that's where, middle of, let's say, 2005, 2006, 2007, you had this big company beginning to think how to make a search with media. And that's interesting because if you look at that in a way of when artificial intelligence began to be the trend in terms of venture capital, when people began to invest, 2012. Why? Because for a computer, Wally, I love Wally. But the computer doesn't see Wally. The computer sees pixels. There is, inside the code, a point. This point is this color at this place. More you have points, better the quality of the picture is. But behind the points, the computer doesn't have any idea what is in behind. So, again, we needed to be able to give a tool to the computer, to the machine, to have the same senses than us. Hearing, speaking, looking, understanding, sorry, bad words. Being able to see and to recognize, and that's why we created all the technology around artificial intelligence to be able, basically, to create Nemo. But when our friend Nvidia, I took that from you. Amazing word, by the way. Amazing. When you see that, that's in real time what the computer is doing when you have a car inside the street and a self-driving car. So it's able to recognize what is exactly the different parameters, and inside that to recognize who is what, but the car by itself, the system by itself behind, the computer, the GPU, doesn't understand what is exactly behind. It's just able to recognize and to match depending on a calculation. So the concept of recognition, of a computer understanding, the concept of intelligence, is stupid by itself. You see what I mean? Obviously. Let's keep following. So, is artificial intelligence really clever? But obviously, I answer the question, but it's interesting to try to understand. You have here, let's say Tom, and you have here Wally. What's the difference between both? Wally without sensor doesn't understand anything. Tom understands everything, but not only with the brain. He's understanding everything with the body, with more than only the brain. And Wally can't do the same things than Tom. It's a bit like Mac and PC, you know, at a period of time. Well, I'm Mac, obviously. So, that's exactly the same for a dog. Look at a dog, I don't know if you have a dog, I love dogs. I have more dogs than cats. Cats are, that's bitches, that's not good. So, dogs in front of a mirror, but doesn't recognize itself. You see the dog, and the dog is like that. I don't know if you tried. And you were so in love with your dog before, and after you go away. You know, that's a bit ashamed. That thing is not true, for example, with an elephant. If you put an elephant and you make a cross, white one, on the head of the elephant, and you put the elephant in front of a mirror, the elephant with himself try to clean the head. It means that the elephant, and that's the same with dolphin, they are having a consciousness about themselves. That's the beginning of understanding. When you take this arm, robots, amazing, what we can do now, the mix between AI and robotic is lovely, but this arm doesn't understand anything about what is touching. We can give back the sensation now, but the concept of understanding is not true. And again, the concept of understanding and of intelligence is very, very complicated, even for us. What means intelligence? That is intelligence, typically for a computer. Ability to calculate a lot, fast, way better than us. We can't compete. And that's why we are absolutely shit in front, exactly like you were explaining, in medicine, in some repetitive task. That's not our task. We are not done to do anything on a repetitive way. But ask this computer to tell you if you have a flu or not. At that moment, just these simple things. You need to match parameters. And to match these parameters are something totally different. It's not high level of calculation. It's something that is more logical. That's a link in terms of reflection that a computer doesn't know how to do. And that's why IBM Watson, for example, is having so much problem inside this field. So, my point today is, I'm a big fan of AI, let's be clear, okay? But my point today is to try to figure out 4 problematic we all face inside I'm inside the timing, yes. Inside this industry and inside the research. First one, progress in narrow intelligence is progress towards general intelligence. Example. OpenAI is nowadays the most developed system able to basically create language on a complicated way. Couple of months ago, you saw OpenAI linking with GitHub to create coding. Basically, what does that mean? Everyone who is learning coding is losing his time. Because today we will have the necessity with this kind of technology and ability to create automatically code, and the concept of coding and learning coding is just a loss of time. You need to understand architecture behind. But when we are speaking about that, we are still speaking about speech. One part of cleverness. We are not speaking about movement, we are not speaking about anything else. So it's still the same type of intelligence. It's exactly the point I wanted to tell. We are not speaking about something global. Second point. What is easy for humans should be easy for machines. That's a big joke. Let me introduce you to Arthur. That's not my children, but anyway, imagine Arthur. You put Arthur, for those who have children, in front of a coffee machine, getting ready for doing coffee. Usually the goal and the answer is all the time the same. Arthur crying. Amazing. For us, it's logical. Arthur will understand the next time that don't put your hand inside the coffee machine. That link is impossible for a computer. This link means, and that's also something that is a limit of data processing and so on we face now. These simple things for us is unbelievably complicated for a computer. That's the second point. Third point, it's a problematic of description, wording. Typically, when we tell artificial intelligence, just the fact that for public, press, everyone explaining that we developed artificial intelligence, people are trying immediately to put that in their word. A computer is reading. A computer is understanding. Guys, a computer doesn't understand anything. That's not understanding, that's not thinking, that's processing data and doing mathematics. And this part is very important. And that's why we all, specialists as we are, press and so on, having a big need of explaining what is happening, because people are facing now worldwide hopes, wishes, fears. Oh, AI will take our job. Please, let's be serious a bit. That thing is very important. That's the third point. Fourth one, intelligence is all in our head. That's a big debate. I'm part of the people considering that intelligence is global, meaning when you have a body, the body is a mix with a lot of sensation, feeling, senses. And that's the same with a sensor for machine able to give you a perception of an environment. When you eat, when you touch, when you hear, when you smell, all of that are giving informations. Without these informations, you can't have a perception of your environment. And without this perception of this environment, you can't process the information coming back to the past, understanding the future, anticipating. So that's a mix way more complicated than only mathematics and data processing. That things is definitely, and we are definitely far, far, far away from any type of artificial intelligence. We can do amazing things in clever software. We can do amazing things in some dedicated parts, banking, for example, and so on. But we can't face, and we are even not close, I will not leave that in my life, to any type of clever software, clever enough to be called as intelligence. So, does it exist? No, I just answer the questions. Mathematics is everywhere, but at the same time, we need to be able also to understand, I'm finishing, to understand that understanding what we are doing and the consequences of AI is also very important, because AI is also for us impacting our life on a bad way, like for example, the fake news we are facing on a daily basis. Typically, that's AI. It's cool, but imagine that on a very high level, and now you understand why politicians are so weak and it's so complicated now to go on. Thank you. It was fun to mess up the day.
Yeah, there will be some questions, and I doubt that people recorded quite a lot of virus videos and put them to TikTok right now.
I have a question. I mean, not really a question here. Yeah.
Be nice.
Maybe not. I don't know. Just a comment. I'm not really in line with what you've said. I'm sorry.
It's normal. You are a specialist of AI. I've been paid, so.
No. I wouldn't qualify myself as a specialist of AI, but it's something I know quite for a while. I think some of you. I mean, I understand the point you want to make, that there is a lot of things wrong that is said today on AI, but I wouldn't be so assertive as you, as we are far from having something that we could call intelligent. And I think first you need to define what you speak by intelligence. There has been a lot of work in the past. People think that it's since 10 years. It's actually since 50 years that we are trying to do artificial intelligence. And there has been a lot of work in the 80s on this subject. And as you said, you cannot learn with a computer. As you said, it's just computation, and I cannot learn from my mistake. There is a big field of learning that is called reinforcement learning, which is exactly doing that in artificial intelligence.
Yeah, but again, I agree with you. DeepMind and everything about Google Brain. I saw the speech about Google earlier. It's crazy what they are able to do with Google Brain inside the department. But at the end of the day, the algorithm is not understanding what it is doing. So
okay, what I propose you is we have a drink later.
With pleasure.
And
with great pleasure for that. With great
pleasure. We are not going to solve that right now here. Okay, thank you.
Okay, having my right as a speaker to ask you a question. So, just your opinion I'm interested in. Do you think we really need intelligent machines that do understand why they're stopping before they see the pedestrian or not? So do you think yes or no?
I think you're fully right. For the moment, we need process of automatization. But the big problem is when we are trying to use artificial intelligence or quantum computing, for example, and to solve problematic of healthcare, or problematic of pollution, and so on, where you are not trying to do any type of automatization, but trying to do the brain way of human to accelerate the research. On that way, it's understanding. And that's a big debate, again, about what is accelerating, not accelerating. I consider today that if I'm not understanding what I'm doing, even if I'm doing it well, it's not intelligence. It's a perfect software of automatization. And all this process is even if the things are moving fast, but that's something very important to explain to the public, and that's also why I took this opportunity to do that.
So you think we need to change the wording? It's not
I definitely think we need to change the wording.
And it's okay.
Definitely. When I have a child who is asking me after a lecture, what if tomorrow the computer will be more intelligent than the father, or things like that, that's a problematic today. That's clear.
Okay, thanks.
Okay, thank you. Can I proceed?
Yeah.
My name is Bogdan. I'm an entrepreneur. So, if you look deep in the future, is it possible to have real AI? Like machine artificial?
I think we will arrive, and that's where I agree with you. I think we will arrive sooner or later because it's going very fast, and definitely with the power of calculation, the quantum computing, the new way of reinforcement learning, and so on, we will arrive at a moment of time with a type of artificial intelligence on level 3, level 4, where you can consider it as intelligence. But at that moment of time, we will face other problematic inside the society, because explain a computer who is able to understand why you need to follow us and as human being, and at that moment of time, we are getting inside the singularity theories and all this type of things. For me, so far, even if that's going fast in some ways, in the next 10 years, it's not on the desk. After, certainly by the quantum computing, accelerating by X the power of calculation. Definitely.
Jean-Christophe, thank you for a bright and strong speech. Mostly with your points, and definitely it's not intelligence, but I'm quite curious about the case when there are some cases actually about the inventions when machine was used into this invention, and some code was developed, and some part of this code wasn't actually clear for inventors, and when they read off of this part of this code from the whole code, the efficiency was dumping, and when they put it again, the efficiency was rising. Can you please try to define what is it?
So you are explaining me, if I understand well, why sometimes when you are using AI to develop some code is better than when you are not using human people, or you are not understanding what is happening inside that?
Yeah, what is the black box, and why we can't understand why is this part of this code?
The concept of black box inside artificial intelligence is basically you put data on top, algorithms on neural network, meaning by slice, are trying to process the data and to get out of this data something that is with a usage for us as human. That's the big concept of data science. The problem of that is when you don't understand what is happening inside the black box, you can't use that, and it's complicated to explain. Typically now, in Industry 4.0, in healthcare, and so on, we need to be able to develop, and that's what is happening, explainability of the black box. What is going on? What was the road of information from the data to the result to access to these results? And typically in healthcare, medical usage, and so on, if you are not able to do that, you can't access and you can't use algorithms, data science on a high level, and all these things for this type of medical usage. Sometimes inside the black box is processing on ways we can't explain because we still are not able to explain fully the process, and that's something I don't know if he's not listening. That's something we are making a lot of research right now. we can't explain everything inside the black box, and that's exactly where we are trying to explain, to understand the road and to understand why this decision was taken at that moment of time. It's still a big process.
Okay, it's like about the science, so we are trying to understand the logic of this
exactly,
of the process.
Exactly.
But it's like it doesn't mean that machine is smarter. It means that we don't see all the.
We don't see the process inside.
Links, yeah?
Exactly.
Okay, thank you, Jean-Christophe.
Nika?
No, last one. No, perfect.
Yeah, so
It's perfect. I need water.
Yeah.
It was a pleasure.
Yeah, thanks, Jean-Christophe. You'll be able to ask more questions to Jean-Christophe and others during the panel discussion. But meanwhile, we have the last presentation for today from Maksym Diachenko. He is the co-founder and CEO of Cardio.ai, and since 2013, he is in deep learning, and he created a very good solution which allows you to do the cardio checkups without actually the involvement of the cardiologist. So, Maksym Diachenko, and next presentation is AI and business. So it will be not only about the healthcare and cardio, but in general, how to allow to business to use AI and how to start the digital transformation in the companies. Thank you.
Добрый день, добрый вечер.
Good afternoon, good evening. My name is Maksym Diachenko, and I am the representative of XOresearch. I am its manager. I'm not going to talk about large AI. I will be speaking about this tiny 5 by 5 by 5 millimeter small AI. It's not even AI, it's neuro AI. But how clever, how intelligent is your AI 5 by 5 by 5 neurons of intelligence? The first question is, does the business need AI? Is this transformation actually needed? Because AI is an alchemy nowadays, it's a magic. And in fact, the majority of people that work in this field do not fully comprehend in what way this algorithm works in the neuronic network. Is exactly what the previous speaker was referring to. And in a certain way, to a certain extent, it's a problem. But the potential of this technology is there, and it would be foolish and dumb to deny it and say that this technology will not happen and will not drive the development of humanity in the future. And here it's worth remembering AI winter. We have already lived at least through 2 of them, and basically the problem lies in the fact that this hypothetical advantage in AI that will allow us to achieve some things that we cannot do via the usual developments, the way that we do it via different expert systems, let's say 20 years ago up until now. It takes a very long time, so long in fact that this red hypothetical line of developers in the expert system becomes functional at a very good level of quality long before AI system begins to perform very nice results. But that dream in the green line still remained a dream. And in fact, modern neuro AI systems take up several years, 3 to 5 years, before you actually arrive at a certain result that can help you in a certain way in your business in the first place. September 3rd, our foreign speakers will not understand the joke. It's the song by Shafutinsky. It's a classic song. Even 3-5 years ago, we said to enter IT. Entering IT meant a process when a company would begin to digitalize certain processes, would begin with some very basic things, at least teach its employees to look into their email boxes that you have been notified of something. And the idea about building such an expert system and the MVP of such an expert system, no matter what the problem is that you are trying to troubleshoot, 1 year means $300,000 in your pocket. Just as simple as that. But if we talk about a neuro AI system, it takes up to 3 years and at least $1 million for the development of such a system. And the anticipations with regard to such a system are much higher than with regard to the usual IT system. So there is also a very simple way to go about it. we can use some external APIs. Amazon, Google, they provide us with various systems that we can employ every day, because business is what? It's a repetitive process, and 90% of processes are really typical. But not on my shift. In fact, the problem lies in the fact that if you use a typical, some kind of a tried and tested thing, it means that you are not competitive, because any ape can take an API even with neuronal networks within, and they can troubleshoot in the same way as you can do it. You don't have a cutting edge when you're trying to sell your product, especially if it's a highly intelligent product. That's something referred to you. That's exactly what it looks like. Nearly every second startup claims that they have an AI system in place. Okay. But inside, just a combination of various small bits and pieces, basic ones and banal ones. And the first question you have to answer, if you want to make an AI startup, if you want to set up such a company, even if you are trying to establish a department within your large company because you have decided you want to enter the AI field, but do you need AI in order to solve your problem? Because the idea is that while you are doing this, you will be using the principle of faking until you make it, and you can die as you're doing it until you have arrived at the AI solution. By then, you can just die of starvation. Very briefly about Neuro AI. Neuro AI requires what? Data sets. If within your company you collect apples, you pick up apples, probably it's very easy to do. You only have to collect your data set. You need to mark apples, and in a way this is already a set of data. Then you need a model. Here it's a bit more complicated, because you can get the model from GitHub. It's functional in many ways, and one of the pillars of AI movement used to say, don't be a hero. Don't try to generate an AI model yourself, because more likely than not, you will not do anything, because architectures are really difficult, they are hard to align, and let the people that earn $1 million a year sit there and sort them out. But your task is take something operational, functional, and build something on top of that. Or just as I did it, make your own model, but okay, it's up to you. Next, you need a lot of iterations. In other words, just integrating on top of the existent AI system is realistic, basically. It takes 1 to 2 years at least, even if everything is functional with you right now. Right from the very beginning, when you showed a fantastic prototype, all the way to the point when you can name this prototype something as functional and capable of integrating, it can easily take a few years. So you do need a lot of patience, a lot of endurance before your system gets integrated. In my case, it was a bit easier because we are just purely an AI startup. So we took one problem, cardiological problem, and this Neuro AI solves one very simple problem. It looks at ACG and looks at what's wrong with it. It's useful. Why? Because this problematics, cardiological problematics, falls back on the thing that the number of people that can interpret ECG schemes are just a handful of people in the world. These are people, they eat, live, they row or fight in the morning with their partner. AI doesn't care for that. If it's good AI, it always does its work equally well. And our AI is a true cardio AI. It's not a fake, because in many cases, a lot of diagnostic cardio AIs, these are basically very simple systems, in many ways based on classic machine learnings, which dates back some 10 years ago. And all they say is, look here, something is wrong in this area. But the problem lies in the fact that in diagnostic cardiology, it's extremely important to understand what arrhythmia the doctor targets. He, the doctor, needs to understand that. So now there is a certain group of ECG technicians who determine this is the particular type of arrhythmia. And this is a big problem because, as I said, such technicians in the world are quite few, just a handful. And by solving this problem, we can troubleshoot for cardiological checkups. It's something that all of us, starting with the age of 35, are supposed to do on an annual basis. Why? Because diagnostics and just treating is much cheaper than try to cure you when the event has occurred, when the worst has struck you. Everything then turns into immense amounts of money, and those who have been through that, they know it from first-hand experience. But we have not just developed this AI, we have managed to integrate it into business processes in some profound leading clinics in Ukraine. So that means that even now you can go and have your cardiological checkup, and please do not put it off. That's important. And it's not only about diagnostics at the level of ECG. You also have to record the signal itself, for which we have a special device. I even have this contraption with me in my pocket. It's very small indeed. You can attach it to your body and just walk and live with it for 7 days. And it doesn't prevent you, doesn't stop you living in any way. Some of you, if you used halters, you know what that means. There are some wires. You cannot have a shower, etc. And it's really uncomfortable. Yura has been walking around with this device the whole day, and no one has noticed it on her. But the idea is we have built the whole cycle. The cycle where the clinic simply puts or tags this device on people's body, and then the magic begins to take place on our side. AI begins to censor all of these signals, and all of they do sometimes, even in their blood, the clinics just sign the results. And mainly what we built our business on is that the 7-day signals, based on old approaches, just as the majority of diagnostics is done these days, usually takes 2 hours of work. A human being sits there for 2 hours checking your ECG. It's nothing stressful, not much to it. But our technicians sign these protocols 5 minutes later. So something that we couldn't do, something that we couldn't scale up, now we can scale up due to automation, neuro AI. And this is the technology is being prepared to be launched across the globe, because although Ukraine for us is a small starting platform, but it's cool that our patients now have the approach to the cutting-edge piece of technology, and that's awesome.
So there's another important thing I would like to highlight is that we do spend a lot of time at work. So every day we do something in that work, burning out, we get tired, exhausted, and the majority of the people never strike an appointment with doctors at his or her will. Do you remember the last time when you woke up in the morning and decided to have an appointment with the doctor? A few of us usually were taken there by either our spouse or even ambulance to the doctors. But before cyborgs have occupied the world, what's so much important is what is driving your business. We don't have any super AI systems that do everything on their own. We still depend on the people that we see again and again at our office, and their cardio problems lead to the early death, premature death. That's extreme, but chronic fatigue or burning out is something that happens again and again. So it's better to spend $10 not on a cup of coffee, but $10 per month. This is what will cost you to test each and every employee of yours. It will cost you $10 per month, but you will have good return on your investment. I mean, if you experience burning out, you know what I'm talking about. When you feel like doing nothing, but your boss calls you and says, "Hey, listen, an important client is visiting us tomorrow," and you say yes. So what I'm talking about is that the company should be the leaders in organizing compulsory checkups for their employees. So in a company, 100,000 of people, every person should be checked up, and this is what we'd like to do. This is what you won't be able to cover with regular cardio diagnostics, using no artificial intelligence. A couple of words about what future holds in store for us. The most important is that it completely changes some of the business models, in the cardio diagnostics. Something that used to be not quite interesting in the past, because I have a technician, I pay him $300 per day, and he does 20 inscriptions per day, so I pay him 15 inscriptions per dollars per inscription. Simple mathematics. So 20 is my minimum, below which I will not work if I'm paid lower than that. In the new paradigm, it will cost you $4, and it gets very attractive. You'll get that margin that you've never had before, and you have an opportunity to grow volume-wise, because we lack people in the past, and this change in business models is an important driver. It will impact the diagnostics a great deal in the whole world, but there's a revolution going on in the hardware as well. This is a cool thing. I work with it every day, and we discuss it every day. We think what's got to be done to move on, and these hardware sensors, the newest ones, they will gather a lot of markers, store a lot of markers, blood pressure, which is an important marker for it. Imagine you have a device that is on your chest measuring your device, and there's nothing that is about to break your arm. So this device will be following the troponin, which is a protein, which is the first sign of acute heart attacks. So this thing in real time is streaming something somewhere, and there's an automatic system that is observing everything, and you need to interact with the person only when something has happened, and you need to tell the person do this or do that. For that, we will need new neural networks, because these contactless sensors usually employ PPG technology. You need new neuron networks that will collect this PPG signal, ECG signal, and they will say, hey, your blood pressure is 25/85. So these neural networks fit in perfect into the cardio AI platform, just like basic neural networks that everything is built upon, that we build upon. And we will definitely do that, but it all leads to a cool thing. We call it health index. A health index is a concept which is built upon already existing scoring systems, Martel the risk. So this is a system, the scoring system, which assesses to what extent this patient is likely over a certain period of time to have died. And the higher this mortality risk, the faster we have to approach the patient. And the idea is that we will be able to use the predictive capacity of the neural networks, not only to say that the person's health index is X or Y, but we'll be able to predict it in the future, in 1 hour, in 2 hours, in 3 hours. The more extended it's in time, the lower the exactness is, but at the same time, this is a safety net saying that this patient in an hour's time may have big problems, health problems, so pay him some attention. And the most important case is when we would like to apply this. Imagine there's an emergency room with tons of patients queuing, waiting for a doctor, but the doctor has no idea who is in bad shape, pretty bad shape, who's okay, So the idea is to, if a patient is pretty bad, we're gonna put a biosensor on him or her, and the doctor, when his doctor goes into the corridor and see who's there using Google Glass, he sees the health index above the head of each of us, of the patients, and if the health index is high, the doctor will pick up that patient and treat him ASAP. That's why we need the artificial intelligence for. That's it. If you've got questions, feel free to ask them. We can get ready the stage for the upcoming panel discussion. This is a cool thing. I do believe that you will have a good future, but are you planning to IPO? If yes, when and what for? Why would you like to IPO? That's a nice question, by the way, and so PAC is much more popular than the IPO. No longer, okay, I've missed everything again. But, okay. It's evident that making cardiodiagnostic automatic is something that may serve as a driver for years and years, and probably external investment will be a solution for the scaling up of this technology. But frankly speaking, even now the margin of one service that we provide is big enough. It's big enough, and it is healthy. I mean, healthy health margin, and probably I don't think that we will be asking audience or anybody else to invest. I don't think we need. Well, cash-in is a good solution, but I don't think we're going to be asking for investment. I'm a doctor in the past, and sometimes to assess the ECG, you need to see with your own eyes the body. Maybe there's some redundant, there's some additional hair on the person's body which impacts the ECG result. Yes, this is a good question. Hairy man is a problem when it comes to the reading the ECG, which is true, and deciphering it. And sometimes that part of the body is shaven so that the quality of the signal be better. But I've even had a picture here of ECG. I see the step. I seen the step. That's a Russian proverb. I see, and that's I'm seeing what I see. So this is what the sensor have detected, and it's the producers of this device to make the signal look this beautiful, because the signal is beautiful, ain't it? No, this is the screenshot from yesterday. This is no drawing of mine. I've been using that. I used that device yesterday, and this is what I have. F1 is 0.96% of accuracy. F1 score is 0.96, I would say. Thank you very much, and I would like to ask you about the company. Psychological burning out. You can control it with cardio devices. Are you ready to do that, or do you need additional artificial intelligence? What I'm saying is that arrhythmia as a problem, medical problem, the more the level the arrhythmia is, well, this is a simple thing. Your pump starts pumping blood the wrong way, and at a certain moment of time, if it's been doing for a long time, your limbs don't get enough blood, or your brain doesn't get enough blood to function. And curing arrhythmia, I mean, the objective is the well-being of the patient. And if your employees haven't been diagnosed, because lots of arrhythmia at the initial stage, you take some medicine and it's gone. So this is a solution to this problem, cardiology-wise. There are lots of other reasons why a person can feel bad, can feel sick. Maybe, I mean, the person feels tired or fatigued, and that's what I've been talking about. I mean, all other vitals, of in the biosensor, creatinine, glucose, hemoglobin. The sensor can read this information. Right now we cannot say the level of glucose that you got using this very sensor, but I think next year using this biosensor we will be able to read the information. If you don't feel well because your sugar level gets higher than a certain level, you gotta see the doctor, you gotta get cured. And this is the answer that the biosensor will give you. And you've said that to test an employee is $10. What is the price of this sensor? $2. And you've said it's single use. Yes, it's single use, and because it's COVID is reigning the world, and now it's a single use device. And this biosensor, I brought mine, and I'm holding it in my hands, not giving it to anyone to touch. And the reason is the very service. If you sum up all the services, if you service one, the price will not exceed $120 per year. So that's why 120 divided by 12, you have $10 per month. Sorry for not giving you the right figure right away. So we figured out that you're not planning to IPO. You have enough income. What comes next? Bionics. We'd like to hear from you. Will you make limbs longer? So I think that the main value of current bionic medicine is helping those people, the disabled people, because you don't feel fine when you don't have arms or legs. And just like in the previous presentation, if bionic hand can be a substitute, well, great. Let's stop person suffering. Then we will put artificial skin onto that bionic arm, and the person may even start feeling something. So the entire brain of ours and the entire neurologic system of us is a unified system, and it thinks. So the goalkeeper chases the ball, and the visual system processes the initial couple of shots and transmits the information down the brain, and then the brain makes the arm stretch out to catch the ball. It happens not only in the brain. And that's from my point of view. I would like to do something probably with the guys from the Nvidia. The next thing I would like to have is to expand the human being's capacity by means of pluggable interface, Neuralink, if you may. Something that will allow your brain in real life with great bandwidth, so to say, stay in touch and socialize with the artificial neural network. For example, you're traveling to China, you don't speak Chinese, you switch it on, you've paid $20 and now you speak Chinese. You disconnect it, you don't speak anymore. You may have some words left in your brain that you've heard in China, but this is something that I'm after. And the final question before we kick off the panel discussion. Igor, my name is Igor. I like your presentation. You've shown some startups, and you said it takes 3 years to get to MVP. The first question: how long does it take it to get to the product market fit? If it takes 3 years to get to the MVP, and how can you shrink? How can you make this path shorter? Probably we need to go for those niches. There's a light version of AI, quantitative, not qualitative data. Probably we need to go for those niches through which you can win better and more, because the very technology is easy. So what would you suggest? How to get to the product market fit phase in the AI industry? It took us 5 years, even more, I would say, in 5 years, and this is a tough process, but if you take a look at the developments, what was done in R&D in 1990, it was the same. People would spend 5 years to take Windows 90 to Windows 95 level. it took him 5 years as well. So the only solution to this problem are the tools and the standardization of the components. Everything that we did in our regular development, we need to do with our AI systems. This is not rocket science. We're more or less aware what we've got to do. With regards of more vectors to pursue, well, I can get a net from GitHub and a dataset from Carvop, for example, and roll out and train the network and show it to someone. There's no value because anyone, you, me, Julia, for example, can do the same. And what is the value? But the value is that you take a problem, you research the problem, because cardio AI was designed. We asked cardiologists how they made decisions. So we simply did everything that the cardiologist told us and made that neural network. So what's the value is that you've researched the problem, you've rolled out the architecture, custom-made one, which resolves the problem, and then you will be awarded. Otherwise, you will